Okay, yeah, so you ready?
Yeah.
Okay.
So in the past, I have talked a lot about how our triple store AllegroGraph works, and I've done some kind of formal presentations about that, and you can find them all on our website. But on our end, we decided that in the coming months, we'll do more demonstrations of what you can do with the triple store. So of course, I will be using AllegroGraph, but most of the show you can do in any triple store. But let's get going. So when we started with AllegroGraph and when we did our first seminars, I still had to explain in detail what RDF was and what a triple was. Now about everyone knows about it, and so what we now talk about is all these wonderful data sets out on the web that are now all public in RDF, and where people are starting to combine them in all kinds of useful ways. So what you see here, I guess most of the people in the audience have seen this picture. This is the web of data. Actually, it's much bigger than here. But if we look at roughly what kind of data sets you have, you see in yellow there's a whole bunch of publication databases. So published scientific papers with the authors, etc., etc. There's a whole bunch of social network analysis sites that are now also available in RDF. Then there's media sites in RDF. Of course, everyone is using the DBpedia, the RDF version of the Wikipedia. I've given a bunch of demos around geospatial capabilities of AllegroGraph, and I always use geonames for my main geo database, and I've done a lot of playing with WordNet and OpenPsych. And today will be about a demo of linked data in the red cloud. And what I'm going to play with is with the database of diseases, daily medicine, clinical trials, drugs, and a database of side effects. In probably 1 or 2 months, I'll also do a demonstration about how we load at Brown's UniProt and UniPark and some other in this area. It was roughly 5 billion triples, and I'll do this demo probably in February and March, where we go more into this one. But for today, we'll go through these ones here. And so what I do in my demo is I take 11 linked data sets. I load each data set separately, and then I federate them into one federated triple store. And as I said, we take 5 public databases. We have Drugbank, and I will go into these databases in a little bit more detail. Then one database that is in the middle of all these databases is the clinical trials, because that contains lots of wonderful information about research about drugs, about genes, about diseases, side effects, etc., etc. But the problem with the clinical trials database is that almost everything is text. So one thing I did first was to look at every drug in the drug databases and link them up to the clinical trials just by plain text search. Did the same for side effects, targets, and diseases. And then France works with a few bio companies in the Bay Area. One of them is Informatics, and for this demo we worked with Alidar, also located in San Francisco and New York. And Alidar specializes in entity extraction, natural language processing of text. They have a whole bunch of vocabularies, ontologies, and they can analyze text and turn that into triples too. So what they did is they looked at rheumatoid arthritis and did much more extensive natural language processing on the clinical trials, and they put that in triples. So I'm loading that too. And then one of the things that happens when you go out in the field and you try to work with all these linked data sets is that initially you have no idea where to start. I mean, you've got a bunch of databases, you know they are somehow connected, but how do you get an insight in what connects to what? So we've written a tool that will take linked data sets, find all the types in there, and then create a kind of a schema space so that it's a lot easier to figure out how one type of entity or RDF type in one linked dataset can be reached through a set of other databases in another database. That was a really bad sentence. So basically, I created a schema space, and you can connect any two types in your total schema space, and you'll find out how they connected through other data types. And I'll give a little demo of that too. But let's first talk about the data sets that I loaded. So each of the data sets the big ones, are actually websites on the web. So one of them is a Drugbank. It's a bioinformatics and chemoinformatics resource. It mostly contains small molecules and FDA-approved drugs. It's got a lot of visitors every day. And if you go to this website, you can do all kinds of searches, but you can only do searches about drugs. So what some people in Germany did, and I hope you can read the links here, but otherwise you just Google for Drugbank and RDF, and you get straight to this page. And if you go to the bottom of the page, which you can't see here, you'll just find the downloads for these data sets. So if you want to, you can just everything I show you today, most of what I show you today, you can just download straight from the web. So anyway, so you take the RDF from this file, and you load it into the triple store. Let me just do that for a second. So I go to Graph. Graph is our visual navigation tool on top of our triple store. And in itself, you can download this tool for free, and it allows you to open triple stores and load triple stores. Actually, there's not even a limit. The only limit is your the hardware you're using. If you do this stuff on a say a Windows 7 box with 4 GB, you can easily go up to 50 million triples and do kind of very interesting research already. But I was talking about drugs, so just let me find the drug. So if I'm in Graph, and I'm now in the Graph view, if I hit the letter J, then what happens is that I get all the types in the database. Let me see, oh, sorry. So here you see the first letters of most of the types. So let's go to the D, let's go to drug. There's drug interactions and drugs. So let me get to drugs. And now what you see is all the drugs that are in the system. And say I'm interested in amoxicillin. Then I can go here, say M. Say I'm interested in the tablets. And so now I have here one item that I can look at. And one way to look at the features would be to hit. So I selected this node in the graph. I hit the letter T, and now I get into the database view. Actually, because of this demo, I just made my screen smaller, and now I see that it doesn't fit entirely into the screen. So let me fix that for a second. Make it small. Okay, so now everything fits in the screen. So what you see here is triples. You see amoxicillin. How do you pronounce this? Amoxicillin? No. Amoxicillin. Oh, sorry. Amoxicillin. Sorry. Amoxicillin has an active ingredient, amoxicillin, and active moiety is also amoxicillin. So that is this is the active ingredient. Then you have the adverse reactions. You have the clinical pharmacology, the contraindications, somewhat of a description, the dosage, the full name, etc., open dosage. And then you also have some things here, sameas, which are interventions. And interventions are kind of the experimental effects from a clinical trial. So I can click on an intervention. And so someone did an experiment where they used 2.5 milliliter of bubblegum flavored amoxicillin, and it was in a clinical trial NCT00106197, so I can click on that one, and here you see the clinical trial, and you see the criteria for when you can be part of this trial. So for this one you have to be depressive and you can't be pregnant. And what I was talking earlier about is that there's a lot of text in the clinical trials, and there's a lot of information, but there's only a few 30, 40 triples. So here you see a description with a lot of text, and here's a small summary, although usually it's a lot bigger than this one. If I hit the G button again, I actually can see how I took a trip from amoxicillin through intervention to this particular trial. And if I hit the letter Z, I go back to every previous step that I've done so far. Actually, it's extremely handy if you navigate through within the table view. It's sometimes very handy to just be able to read the text and just do a whole trip in the table space. But it's always great to go back to your graph view and be able to see the whole trace of all the things that you were visiting. And you can go back, of course, to any halfway and then continue. Okay, so that was I was talking about the drugs. Let's go back to the presentation. So the next thing we took was the clinical trials, and I've just shown you one. It's the clinical trial database has about 81,000 trials sponsored by the NIH, and it's a very, very popular website on the web. 40 million page views per month, 50,000 visitors daily. Again, you can go to the web and just do searches there. Then there's a database, the CSOM, with a network of 4,300 disorders and disease genes, and well, a whole lot of associations between them. Again, it's a separate database. Then there's a database, Daily Meds. So Drugbank mostly contains the small molecules that are FDA approved. The Daily Med is much more about all the drugs that you find in the pharmacy, and so it's got all the brand names. So just for fun, we can go back to Graph. So say I'm interested in Zestril. I hit a semicolon, and that brings me into the free text query. Actually, everything I do here, usually I can click on add, and then you can say add triples by free text query, or add subject nodes by free text query. I'm kind of used now to all the keystrokes. It makes navigation very easy, but if you begin, everything I do actually can be done through the menu. But okay, let's do it. So let's say, let's find Zestril. And here we find a tablet. So now we have Zestril tablet. And I can hit T again to get into the table view. And I can go back again to the graph view. So I can find all kinds of. One thing you can find in the pharmacy is Advil. And then you see that it's actually the same as ibuprofen. And another way that I haven't shown you yet to look at things in this graph view is actually to hit I, and then here you see all the outgoing and incoming links. So on the left hand side you have the outgoing links from a node, and on the right hand side you have the incoming nodes for that for nodes. So I can select them. Okay, and so I could hit F, and I find that for ibuprofen there's already more than 300 links, so I can click on select, and I could actually select some things I was interested in, and then I get the graph view, which in some cases makes more sense. Let's go back one step. So we have ibuprofen. Actually, let's get rid of Zestril. I got rid of everything. Okay, let's do Advil, ibuprofen. And sometimes I'm going to do something where I want to find some links between two drugs. but when I try to find these links, then the layout will change. So I hit the letter P, and now I kind of pinned ibuprofen to the background, and I can say, okay, also let's look at heroin, and here we have heroin, and let's also pin that to the background, and let's see, can I find any relationship between these two? I hit Shift F, and then I try to find the relationships. And so I find now that ibuprofen and heroin are both small molecules. It's taken by humans and other animals. It's an analgesic, it's a drug, it's solid, and actually it's referenced in both these two clinical trials. Now actually what you see when I hover over, say, heroin, then what you see at the bottom is the actual URL for this particular drug. Yeah, so it comes from the Drugbank, and the number, that's kind of a standardized number, is DB and then 01452. But what Graph does is whenever it sees something, it always will try to find if there's maybe a label for this thing, so that it's a lot easier to read what you have, because DB01452 isn't really that descriptive. Of course, this is something you can turn off. I think there's a thing here, use label properties for the node labels, and now you see that things just have their the formal names, but I don't want to live in that space, so I click this on again. Okay, and okay, let's continue. So let's delete this. One thing that we have is an eraser tool where I can delete parts of the screen. So if I hit Ctrl-Shift-X, then I can start kind of erasing parts of my screen. Okay, where am I? Okay, let's go back to the presentation. Okay, so I got into daily maths and I got sidetracked in Graph, but I've shown already more properties of Graph. Then we have CIDR, a database with side effects. And in my further demos, you see a lot of queries that actually talk about side effects. So let's not go into the database right now. Okay, so I've discussed the 5 databases, and these 5 databases are in many cases linked by sameas relationships. But it's a lot of work for people to create all these side effects, and sometimes you want to make that a little bit more automatic. So in this case, I did first a very simple trick. Because I wanted to link the drugs and the diseases and the side effects and the targets and even the genes to clinical trials. And so I took every drug and looked up the label for drug in every clinical trial. So it's kind of brute force. I looked at every side effect, every disease, and I created a lot more triples of the following nature, like clinical trial, this one discusses the side effect headache, and it discusses the drug aspirin, and also the disease alcohol addiction, and it targets some protein. Yeah, so this is the additional information. And so on top of, say, roughly 10 million triples, I create another 2 million triples of relationships. And then we worked with Alidar, and this is just the beginning of a project we're doing, but it's already interesting to look at some of the results. So what they used is extensive vocabularies and ontologies to look at part of the clinical trials. And so what they did is they looked for drugs, genes, and side effects, but just straight from their ontologies. And given the time that we had, we only looked at rheumatoid arthritis. And so we got another 50,000 triples out of that, but much better information than just plain text search, what I did earlier. And okay, I think I've discussed now most of the databases that I have in one federation. So let's do some SPARQL and Prolog on top of this. So I will show you a SPARQL query where I say, give me the title of all clinical trials that discusses the drug Lipitor and the side effect diabetes type 2. And then I will use the data from Alidar to say, okay, give me all the trials that discuss arthritis and give me the genes and the drugs discussed. And then I will do some Prolog queries. So let's go back to Graph. And one view that I haven't shown you is the query view. Now I can go here, and what you can see is you always can go to a graph view, a table view, and a query view. And so query view is W. Most of the time I just choose W, and I get into the query. And then I want to find a particular query that I've pre-cooked. And we also can do load query strings and save query strings. So if I hit load query string, then I have a bunch of queries. So let's start with this query. So here I guess most people in the audience can read SPARQL, so I'm not going too deep in detail. I'm not going to explain SPARQL. But basically we say find every drug side effect trial and title where there's a drug in the drug bank with the brand name Lipitor, and there is a side effect that has the label type 2 diabetes, and then find every trial that discusses this drug and it also discusses this side effect. And then if I find those, give me the brief title of the clinical trial and just show me the first 5. Yeah. So I do the query, and boom, I get 5 results. And so what you see, just like in a relational database, there's a result set with 4 columns. So there's a drug, the side effect, a trial name, and the title. And what I can do is I can also show you to create the visual graph from the results. So click on this. And what you see here is well, basically the same information you saw in the title, but now with the relationships between all of them. Now, for some people might find this interesting, and you might want to show this to a colleague. So one of the things we also can do, we can say File, Save Layout State. And I could say, well, say result of query. Well, let me say for Steve dot layout and do save. Then say I delete all this stuff. Then later on I can just go here. I say load the layout state, and I say for Steve the layout, and I get the layout back. But what is really interesting is that from then on I can just keep going again. So I can say, well, give me the verification date, and I find a verification date for this trial. These layouts are actually just plain text files, so you can send over email. You can read them. They've got the full URLs in them. Very handy to send to other people as a result. Okay, so that was the first SPARQL query. Let's do another SPARQL query. That's the one with the Alidar with the genes. So let me see, where is queries. Build another query stream is find genes. So here you say find the clinical trials, drug side effects and genes, where Alidar mentions drug and side effect and a gene, and give me the first 50. And now I find 50 combinations of a clinical trial, a drug, a side effect, and a gene. Again, this is much better on the screen. And you see that these trials have these infections, well, these side effects. By the way, if I click here on the side on a, so what you see here on the left hand side is the names of the attributes, and if I click on them you see them activated on the screen. And the other thing that Graph does is that for every node that you see on the screen, it will always try to find also the class of the thing. So that also makes it much more readable, because instead of just colors you will find all the types too, and you can look at all the genes, and you will find the genes in this database. I can find these relationships, of course, also completely automatic. So let me, oh, I don't know what I did. Let me do this. So say just for fun I wanted to find a relationship between this trial and this trial. Well, I go to I again, so to see the things that I want to explore, and I say, okay, I want to only explore, well, I can explore everything, and I could say, so how is this thing related to this thing? And I will probably find, oh, we'll find some relationships. We'll find relationship through trials. They both require that you're 18 years. That's interventional. The point I wanted to make, you can go and find automatically relationships between clinical trials. Completely automatic. Let me go back a little bit. No, this is probably good enough for now. Okay, the next thing I wanted to show is I do queries. So what sometimes happens is you have one particular clinical trial, and you want to say, give me all the clinical trials that are very close to this one. Or you find a particular drug, and you say, okay, find me all the other drugs that have the closest description to this particular drug. Well, it's really hard to express that directly into a query language like SPARQL. And so I wrote some additional code that will look at a set of predicates and will find all the other, in this case, clinical trials that have the most predicates in common. But I shouldn't do this with words. Let me just show you. So say find close clinical trials. So here, this silly small screen. So here I say this is prologue. Select every clinical trial and frequency and title, and then the first thing here is a prologue clause. So I say give me all the articles that are close to this particular clinical trial, and then look at the diseases, the side effects, the drugs, and the targets. Give me the first 5 results, and then give me the names of the clinical trials and the frequency for this particular clinical trial. And then when I find these clinical trials, find the brief titles. So I evaluate, and so I get 5 articles. 5 articles that are closely together. It has got 19 the same items with itself, obviously. So there's 19 values for these 4 predicates, and then the next one that is close together is so this was for wound installation, and this is for skin and soft tissue infection. So you kind of see it's the same thing, although the other ones I don't know why they get so many links. But let's just look at them. And so you see that they have so here are the 5 clinical trials, and say now you want to do a little bit more research to figure out why they are close to each other. And so what you do is you go to I, and let me deselect all the predicates, and then let me only look at, say, discusses diseases, drugs, side effects, and targets. Copy. Okay. And then again I say, okay, so this was the topic of the trial. Let's see, why was it close to this one? And then I find that these things have pain in common, vomiting, hypersensitivity, an AV block, a heart block, nausea, clotting, etc., etc. I can go a step back and say, okay, what is this thing in common actually with, oops, Shift F, what is this thing in common with this one? And mostly the same actually. So this is a whole different way of doing queries, but again, it fits nicely into this this paradigm. And then I'm close to doing the last part of the demo. So what happens a lot if you download these things for yourself in any tool, then you have no idea how to start and how to see whether particular things are related to each other. So what I did is, what we did was we wrote a tool, and we're actually still working on it to make it much more easy to navigate the schemas themselves. For people that are familiar with RDF and OWL in the audience, you know that if you do it right, then for each predicate you tell what the range in the domain is. So basically you already tell, if you see a particular predicate, then the first part of the triple would be of type 1, and the object of the triple should be another type. And that already would give you a great pathway through schema space. But if you go through the linked datasets, you will see that in many cases these things are missing. So what I did is did some additional search. Let me see. This is the one. Resume slideshow. So what I did is I created some additional triples to, it's a little bit of like data mining, where you look at a whole bunch of objects, you find the types, and then you try to find out how to link to other types. So one way of doing this is to say, okay, well, I hope you can see my cursor here now. Yeah, I can see the cursor. So I have an object of a type T1, and then I just find every thing it points to that is a resource, and then I just find the type. And then I will say, okay, there's a connection between the two. This is simple. And actually, this is what people already should do anyway by using range and domain. But again, it doesn't happen that much. Or what you can do a lot is, and this is actually what happens all the time in the databases that I loaded today, is where you say, okay, well, I have a type, T1, and it points to an object, and that object is the same as something else, and this something else is in another database that has a type. Yeah. So now again, you have a prototype of a SPARQL query where you now know how to get, say, from a drug to a clinical trial. Or the other thing is you have a type 1 and a type 2, two different ones, and they point to the same object in another database. Well, then you know again that they're the same. Or these two types point to the same thing, but one of them has the same as. And there's more ways you can look at these connections. But it makes it easier to write your SPARQL queries. So what I do for that is in Graph, I can say get a query where I load a query string. So this impressive SPARQL query will give you all the types in your database. So select distinct every X, where X is the RDF type class. And so you get here all the classes in the database, and say, let's do some random selection. So I take an enzyme, and say, what shall I do? An organization. So we have enzymes and organizations. Then again, I deselect all in and outgoing. And then I say, okay, I just want to know whether they're connected or not, and who are the intermediate classes. And then I say, okay, connect. Well, I need to connect direct. No, I just want to say whether there's a connection anyway. Copy. And then I can say, so is there a connection between an organization and an enzyme? And then I will find that in my SPARQL query, I can go through an offer, which is mostly the same as a drug. I can go through a gene that is investigated by a particular organization, or I can go through diseases. Let's say a particular organization might be interested in diseases, and there's an enzyme related to a disease, or there's targets. And so I can make this more and more complicated. And oops. And here you see a whole bunch of relationships within the database. If I want to, I also can get the names and the types of the relationships, but I think we should keep it at this today. So this is the end of the demonstration.
Okay.
And
Thank you, Alex.